Welcome to the Explainer. Today, we're going to decode the secret language that pretty much powers our entire digital world, data. We're going to crack open the fundamental building blocks so you can really get what's happening inside every analysis, every algorithm, and every app you use.
Let's kick things off with this fantastic quote from data scientist Josh Wills. It just perfectly nails why our main character for today is statistics. Because really, at the heart of making sense of any data is a deep, real-world understanding of this field.
But making sense of data isn't always about wrestling with some super complex algorithm. It actually starts with simple, almost philosophical questions, like this one. Can you multiply blue by brown? Now, the answer seems totally obvious, right? But understanding why it's so obvious, well, that's the key to basically everything we're about to cover.
So to answer puzzles like that, we need a set of rules, sort of a grammar for this language of data. And that's exactly what statistics is. It gives us a solid framework to work with information in a way that's logical and consistent.
Think of it this way. If data is a language, then statistics is its grammar. It gives us the essential rules and the structure we need to move past just collecting raw information and actually start building real, meaningful insights from it all. And a lot of the time, when we say statistics, we're actually talking about these guys, these specific tools. Each one is a single number, like the average or the mean, that helps us summarize huge amounts of information. They let us understand a whole data set with just a single glance. They're really the essential toolkit for anyone working with data. So how do we even start speaking this new language? Well, the good news is that all data, no matter how complicated it seems, can be sorted into just two main families. Getting this first distinction right is, by far, the most important step. And check this out. This chart is basically our roadmap for the rest of this explainer. See how everything branches out from one big split? It all comes down to this. Is your data describing a quality, or is it measuring a quantity? Let's follow these two paths and see where they take us. All right, now let's explore these branches, one by one. Because understanding each of them is how we're finally going to get the real answer to that question about multiplying eye colors. So first up, we have categorical data. This is all about qualities or characteristics. Just think of it as putting things into descriptive boxes or slapping labels on them. It answers the question, what kind is it? Not how much is there. Now, the simplest form of categorical data is something called nominal, which honestly is just a fancy word for names. The crucial thing to remember here is that there's no natural order or ranking to these labels, none at all. So let's circle back to our puzzle. Can you multiply eye colors? Of course you can't, and now we know the statistical reason why. It's because blue and brown are nominal data. They're just labels. They have no mathematical value. You can't do math with them any more than you could multiply apples by oranges. Okay, next up in the categorical family, we have ordinal data. Now, we're still dealing with categories, but here, the order of those categories really matters. There's a clear ranking involved. A perfect example is a restaurant review. We all know that best is higher than better, and better is higher than good. The order is obvious, but here's the catch. We have no idea if the gap between good and better is the same as the gap between better and best. Those intervals aren't uniform. All right, let's jump over to the other side of our data map, numerical data. This is where we finally get into the numbers, the countable, measurable quantities that we can actually do all sorts of math with. So, inside this world of numerical data, our first stop is discrete data. These are values you can count in whole numbers. They're separate and distinct. I mean, think about it. You can have one car, two cars, or three cars, but you can never, ever have 2.5 cars. For example, a class can have 15 students or 16 students, but it can't have 15.5 students. It just doesn't make sense. Same thing with clicks on a website or products sold. They're always finite, countable things. Now, on the flip side, we have continuous data. This stuff can be measured with incredible precision inside a range. Unlike those whole numbers in discrete data, continuous data can take on any value, including all the fractions and decimals in between. Just think about measuring someone's height or the temperature outside. Between any 2 points on the scale, let's say 172 centimeters and 173 centimeters, there are literally infinite other possibilities. You're not stuck with whole numbers. The only real limit is how precise your measuring tool is. But this is where things get really, really interesting. because hidden inside continuous data is the answer to another critical puzzle. It sounds so simple, but the actual meaning of the number 0 can completely change how we interpret everything. The whole answer lies in the difference between two subtypes of continuous data, interval and ratio. And believe it or not, the entire difference comes down to what 0 means. In one case, 0 is just another number on the scale, but in the other, it means a complete and total absence of something. Let's break that down. Think about 0 degrees Celsius. That doesn't mean there's an absence of heat or temperature, right? It's just a specific point on the scale. That's interval data. But what about $0? Well, that means a true absence of money. That's ratio data. And because it has a true 0, we can make really powerful comparisons, like saying one person earns twice as much as another. You just can't do that with temperature. Okay, deep breath. We've cracked the codes, we've navigated the data map. Now let's put it all together into a powerful toolkit that you can use anytime you're faced with data. Here it is, your ultimate cheat sheet. This table sums up the power of each data type we've talked about by asking just a few simple questions. Can you put it in order? Does it have equal intervals? And the big one, does it have a true 0? Answering these is exactly how you'll know you're picking the right tool for any job. Look, understanding these distinctions isn't just some academic exercise. It is the absolute first step to asking the right questions, choosing the right way to analyze something, and making smarter decisions with the data that's all around you. From the daily weather report to your company's latest sales figures, you now have the key. So what secrets are you going to unlock next?